So 6.3, what happens to the lipids when they're in the body? We're going to discuss the digestion, absorption, and transport of lipids. We're going to describe the effects of the enterohepatic circulation on cholesterol metabolism, and we're going to explain the primary role of the adipose cells, or the fat cells. So, some fat digestion occurs due to the action of salivary lipase and gastric lipase. ACE is an enzyme, lip is standing for lipids, so it's a lipid enzyme. The small intestine is the primary site of lipid digestion. We've got fatty chyme in the small intestine. Remember, chyme is the stuff that is going to be released from the stomach once the stomach is done processing. And it stimulates the release of cholecystokinin. Cholecystokinin, or CCK, signals the gallbladder to release bile. It's used to emulsify, again, split apart and separate lipids in the watery environment of our small intestine. Basically, instead of allowing the lipids, kind of like in the salad dressing mix, to kind of bubble and get back together again, this keeps everybody separated. It keeps everybody dispersed. CCK actually stimulates the pancreas to release its digestive enzymes. One that is included is pancreatic lipase. ACE, enzyme, lipid, so it's a lipid enzyme. So when we talk about what we're doing with these lipids, you can have triglycerides, or you can get rid of one of the fatty tails, and it's a diglyceride. You can get rid of two of the fatty tails, it's a monoglyceride. You can also have just free fatty acids or the glycerol all by itself. But when I'm digesting with my enzymes, I'm breaking these down. So, bile contains bile salts. Bile salts are what aid in lipid digestion as well as absorption. They do have hydrophilic heads and hydrophobic tails that can surround lipid particles and form what we call micelles, okay? Here's a micelle. It's kind of this independent unit that has lipids in the middle that are protected from the horrible watery environment of the small intestine. Micelles are the things that transport the lipids to the absorptive cells in our small intestine. The action of the bile salts actually increases the surface area. By making it into smaller and smaller pieces, I'm exposing more surface of the lipid so that it's available for that pancreatic lipase to get to actually break it apart into pieces. So when it comes down to it, if you think about it, if I have a whole piece of steak and I pour acid on it, the only part of that steak that's going to get exposed to the acid is the surface where I'm pouring the acid, right? If I cut it into itsy bitsy tiny pieces and then I pour acid on it, that acid is going to have a lot more surface to get to so that it can kind of, break it apart. Ultimately, that's what we're doing with the bile salts. We're breaking a big, massive glob of fat into little teeny tiny pieces, giving more surface availability to the pancreatic lipase so that it can actually get in there and cut it apart. There's a video called The Role of Bile in Lipid Digestion. Again, it'll be at the end of this PowerPoint, or you can go to your book and look at it there. So the enzymes that we have. Triglycerides are glycerol with our 3 fatty acid tails. Pancreatic lipase will remove 2 fatty acids from the triglyceride, so you end up with monoglyceride. Forming a monoglyceride, a single fatty acid attached to the glycerol backbone, and 2 free fatty acids. Okay, so you've got 2 free fatty acids and the monoglyceride. The phospholipids that we ingest are digested by phospholipase. So again, phospholipid, ACE is an enzyme, it's a phospholipid enzyme. That actually removes the 2 fatty acids. So we had the head and the 2 tails, we're removing the 2 fatty acids. Cholesterol. Believe it or not, cholesterol does not undergo digestion. We absorb it as is. Now, the end products of lipid digestion are going to be the glycerol all by itself, the free fatty acids, or we can have the monoglycerides with the free fatty acids, and then we've got the phospholipid fragments with the head and the 2 tails. So, the actions of so lipid digestion summary. The actions of salivary lipase and gastric lipase. Salivary, it's going to be in the mouth. Gastric, gastro always means stomach, so it's the mouth lipid enzyme and the stomach lipid enzyme enable a small amount of lipid digestion to occur in these two places. So I've got the salivary lipase, I've got the gastric lipase, I've got the big fat globs, okay? In response to the presence of fatty chyme in the duodenum, so I'm starting to empty into the duodenum. The gallbladder will release bile. There's my gallbladder releasing bile into the chyme. Bile contains bile salts, which emulsify the lipids. That is, it keeps the lipids suspended as tiny particles, the micelles, in the chyme. So I'm releasing this, and that big lipid droplet gets split into smaller lipids because I've got that surrounding little capsule that allows them to stay split up. The pancreas will then release pancreatic lipase. Pancreatic lipase digests fat by removing two fatty acids from the triglyceride molecule. The action converts most triglycerides, fats and oils, into monoglycerides and free fatty acids and a glycerol. So I can either take all of them off, I can take two of them off and leave one, but I end up with my triglycerides becoming monoglycerides, free fatty acids, or just glycerol and then the free fatty acids. But either way, I'm splitting this apart. Now the cholesterol, like I said before, doesn't have to undergo digestion. Cholesterol, I'm going to absorb it. So, glycerol-free fatty acids, monoglycerides, are major end products of lipid digestion. So the micelles that we've formed, in the center is where we have our free fatty acids, we've got our glycerols, we've got our cholesterol. The micelles form again and transport the lipids, including cholesterol, to the absorptive cells. So when it comes to lipids being absorbed, the micelles actually transport the end products of lipid digestion to the villi, to the little fingers in the small intestine. So here is an absorptive cell. It's one cell. And I am going to take this to this cell, okay? The short and medium chain fatty acids will directly enter the portal bloodstream. They just go past and go into my bloodstream. But the absorptive cells of the small intestine will form something called a chylomicron with other end products of lipid digestion. Chylomicrons, this little dude right here, is a lipoprotein, meaning it's a combination of a lipid and a protein. The thing that makes it special, though, is because it's that combination, it is water soluble, and it'll transport those lipids through the bloodstream if I want them to. So the absorptive cells remove the end products of lipid digestion from reformed micelles. The short and medium chain fatty acids enter the villus and travel to the liver via the hepatic portal blood supply. Monoglycerides and long chain fatty acids combine to become triglycerides again. The absorptive cell, this cell, packages the triglyceride with some cholesterol and coats the particles with a protein and phospholipids to form the chylomicron. Basically, I am putting the lipids that don't like the watery environment of the blood into a protective shell so that they will move. And in this case, because of the size, because they're this big, they're actually going to go into the lacteal. They're going to have to take a different route to get into the cardiovascular system. So the chylomicrons travel through the lymphatic system to the thoracic duct where they enter the bloodstream. So we kind of discussed this before, but in these villi, I've got my little capillary beds, but I also have this particular vessel called a lacteal. The lacteal has bigger spaces for these things to get into than blood vessels. Blood vessels have little teeny tiny microscopic windows for things to get into. This thing is pretty ginormous. It's not going to fit. The lacteals have these trap doors that open and make a lot bigger openings, which means it is a lot easier to get this chylomicron into the lacteal. Now the lacteal eventually does, through this kind of detoured route, end up dumping back into my circulation. But it has to take this detour in order to get back to that general circulation. Now, lipoprotein lipase is an enzyme in the capillary walls, inside of my capillaries, that breaks down triglycerides from the chylomicrons as they move throughout our body. So, the summary. The stomach only has minor digestion of fat by both salivary and gastric lipase. That all takes place in the stomach. The liver produces bile, which is stored in the gallbladder, and released through the bile duct into my small intestine. Okay, so you can see the bile duct coming out there. Okay, bile aids in lipid digestion. Basically, again, I'm emulsifying it. I'm breaking it up into smaller pieces. And it by emulsifying the lipids in the digestive juices. The pancreas secretes a mixture of enzymes, including pancreatic lipase, into the small intestine. Now, the small intestine is the primary site for digestion and absorption of lipids. Cholesterol requires no digestion, like I said before, but once it's absorbed, short and medium chain fatty acids enter the capillary via the villus, or of the villus. The absorptive cells reform those long chain fatty acids into triglycerides and package them into chylomicrons that enter the lacteals, and eventually through that detoured route will enter the bloodstream. By the time that we get to the anus, there's less than 5% of undigested fat that will be excreted. Now, why is that important? Because fat is necessary for us. We have to have it for our cell membrane. We have to have it for insulation. We have to have it for padding. We use it as an energy source. We don't necessarily want to get rid of it if we don't have to. In a perfect world, I'll put it that way. So, most bile salts. So let's talk about enterohepatic circulation, recycling of bile salts. Enterohepatic, it's inside the liver. Hepatic means liver. So recycling bile salts. Most bile salts end up reabsorbed in the ileum, in the last part of our small intestine. The liver will then use those pieces of bile salts and recycle them. So I'm going to reuse it again. So I'm absorbing it, taking it to the liver, making it into new bile salts to make bile, and then using it again. So it's recycled. This is the enterohepatic circulation. It goes back to the liver, So most of the bile salts are absorbed in the small intestine's ileum. The liver recycles and uses bile salts to make new bile. Eating foods that contain soluble fiber, though, can interfere with this recycling process. So, how do I interfere with enterohepatic circulation? We can reduce the blood cholesterol levels this way. When there is no bile salt to recycle, it must remove the cholesterol from the blood and make new bile salts. So, when we consume soluble fiber, it kind of holds on to these bile salt pieces and the cholesterol that is in these bile salt pieces. So, when we go to the restroom and we excrete this bile salt product, our liver can't use it to recycle and make new bile. I actually have to start over. So where do I get the cholesterol to make new bile salts? I have to take it out of the body. So cholesterol that would normally be floating around the body, I'm pulling it out of the body. That means that I am technically lowering the amount of cholesterol in the body. So, without a supply of recycled bile salts, the liver has to remove cholesterol from the bloodstream to make new bile salts. As a result, the blood cholesterol level drops, which can be beneficial for health because, as we know, high cholesterol can cause cardiovascular disease. When we talked about this before in Chapter 5, we mentioned that these soluble plant fibers can actually interfere with our ability to reabsorb cholesterol, reabsorb bile salt, so it goes out with the waste. So this is why this is important. This is why being able to do this is important. This is why soluble fiber is important. So, using triglycerides for energy, because again, this is one of the things that we talk about. We use it for energy. So, comparing energy density. For 1 gram of fat, we get 9 kcals of energy, compared to 1 gram of carbohydrate, where we only get 4. So that's over twice as much energy. Adipose, very fancy way of saying fat cells, remove free fatty acids and glycerol from the circulation and reassemble them into triglycerides and store them inside the cell. If you look at this cell, the majority of the room in this cell is taken up by a fat droplet. So it is actually a storage facility for our fat. When the body's cells need energy, the adipose cells will break down the stored triglycerides into fatty acid and glycerol molecules and then release them. Why? The cells can remove the fatty acids and actually metabolize them for energy. I can break this fatty acid down and make energy out of it. The liver can actually take that glycerol, kind of shuffle around some pieces and convert it into glucose, which is our primary carbohydrate energy source, which is beneficial to us as well. So both of these things allow us to use fat as an energy source. So lipid consumption patterns. We're going to recall the percentage of fat in a typical American diet and the AMDR for the fat. We're going to discuss dietary guidelines, recommendations for fat and cholesterol intakes. So the AMDR for fat is 20 to 35% of total calories. So the acceptable macronutrient distribution range is 20 to 35% of our total calories should come from lipids. That is the so in 2017 to March 2020, the average fat intake was about 36% of our total calories. So it was higher than what they were recommending, okay? According to the dietary guidelines, saturated fat intake should be less than 10% of our total calories. In 2017, March to March 2020, the average saturated fat intake was about 12% of our total calories. Again, we're higher than we're supposed to be. It's only supposed to be 10%. We're at like 12. Per the dietary guidelines, cholesterol and trans fats intake should be little as possible with a healthy eating pattern. Trans fats and cholesterol are known to cause cardiovascular disease. So when we're talking about, consuming lipids, we want to keep trans fat and cholesterol as low as we possibly can. Nutritional labeling for the lipids. We're going to use a nutrition facts panel to determine the amount of total fat and various types of fatty acids in a serving of packaged food. We're going to compare total fat and saturated fat contents of packaged foods. So, looking at a food label, we've got total fat, we've got saturated fat, the grams of that, trans fat, and the cholesterol in milligrams. These are going to be our listings for the fats that we have in our product. You can have labels that have polyunsaturated and monounsaturated fats, but it isn't a requirement to have those things. Although I will say, because of the health benefits of polyunsaturated and monounsaturated compared to saturated, if you are a smart, seller of food, I don't know, you'd probably want to include them to show people how good your product is.